Yes, hello everyone and welcome to today's video. And in this video, we'll be talking about access level modifiers in C Sharp. What is an access level modifier? What they do, how, what are their types, and which ones are the best ones to actually make use of in the C Sharp programming language. So let's get right into it. First, what is a C Sharp access level modifier? Access modifiers in C Sharp are applied to classes and any class member. They control how the class or class member can be accessed within or outside of an assembly. Well, is let me repeat that again. Access modifiers in C Sharp are applied to classes and any class member. They control how the class or class member can be accessed within or outside of an assembly. So let's break down these terms down. Let's break them down a bit. So the first is a class. What is a class? Never forget, I did that in my previous video. You can go and check that out where I talked about classes and namespaces. A class is a blueprint for creating objects. It's just as simple as that. A class is a blueprint for creating objects. And let's look at class member. Class member is a new term we got from here, which is yes, class. We said access modifiers in C# are applied to classes and any class member. We've treated classes. Now let's look at what the class member means. A class member is any field, method, or constructor declared within a class. It is any field, method, or constructor that is declared within a class. And then finally, the last term was assembly that can be accessed. It controls how the class or class member can be accessed within or outside of an assembly. Now, let's look at what an assembly means. Assembly, this is one or more executable output files created after we compile our code with the command.net build. Again, this is one or more executable output files created after we compile our code with the command.net build. So after compiling your code, after compiling your code, a new file will be created with that as the .dll extension. I might actually do a video on this, yes, that explains how your code is being run right from you typing in .NET build in your command line. I might do a video on that also. Then access files end in .dll or .exe. When you are building a C# application, the moment you run .NET build, a new file with the extension .dll or .exe will be created for you. .dll, it might be .dll or .exe. It might be .dll or .exe depending on your operating system. And we can find these files in our projects bin folder. When you run .NET build, C# creates two folders for you. The first is the bin and the second is the obj. Inside of this bin folder, that is where you can get in your assembly files. Let me just quickly explain something. Many a time actually, what software developers sell is not their code. Rarely would you see a software developer selling his code. What they sell is this .exe file or the .dll file, and the .exe file basically means the application entirely. That's the only thing a software developer sells. So let's proceed. In other words, access modifiers or access level modifiers, yes, for short, you can just call them access modifiers, but if you want to call out the entire name, you can say an access level modifier. They control the visibility of a class or class member. Again, they control the visibility of a class or class member. It is the degree to which a class or class member can be seen. It is the degree to which a class or class member can be seen. They control the visibility, they control the visible nature of a class or class member. And it can also be regarded as the degree to which a class or class member can be seen. Now let's look at types of access modifiers. There is a public, there's a private, there's a protected, there's internal, there's a private protected, and then there's protected internal. For the sake of the technical, for the sake of this YouTube channel, we would only be making use of three, which is public, private, and then internal. We will cover what private is, what public is, and what internal is very soon. So let's proceed. Now, let's take a look at the next image. This image is a very, very, very fantastic image. It took me days before I could understand this image, to be very honest with you. This image is describing, fine, you said an access level modifier defines it is the degree to which a class can be seen, or it is the degree to which a class or class member can be seen. Yes, it is the degree to which a class or class member can be seen. Now let us now look at this table now. This table outlines the 6 access level modifiers we have: private, protected, protected internal, public, protected, and internal. It outlined the 6 of them. Then this is now what it now did. It now picks them one by one, explaining them. Yes, it's now picking them one by one to explain them actually. The first is within the class. A public and a class or class member declared with the public, declared as public, will be accessible, one, within the class, two, within a derived class. There's within a derived class, whether within a derived class, same assembly. Within a non-derived class, same assembly. Within a derived class, different assembly. And within a non-derived class, different assembly. This is a tricky table, to be very honest with you. It took me days to actually understand it. I'll take that again. The first we picked was public. And then what this is saying is that any class or class member declared with the public access, declared as a public access modifier, it's the element, the content of that class or class member will be accessed, can be accessed, one, within the class, within the file itself, two, within a derived class, same assembly. It's inside the same project. Yes, it's inside the same project. Assemblies, you can take assemblies like this. Assemblies, when you are making a C# application now, you can have, let's say I'm making a C# game to for rock, paper, scissors. The first project, my first directory will be rock, paper, scissors dot solution. That's the entire code. Then the next can be rock, paper, scissors. Rock, paper, scissors is where I will be writing in my code file and my project file. Then the next can be rock, paper, scissors dot tests, which is where I'll be keeping my test and the like. So you can take rock, paper, scissors as one assembly and rock, paper, scissors dot test as another assembly to actually understand this very well. So if there was a derived class inside rock, paper, scissors dot tests, trying to access a class inside rock, paper, scissors. Yes, a derived class inside rock, paper, scissors dot test. There are different folders. A derived class within inside rock, paper, scissors dot test, trying to access a derived class. So trying to access a class inside rock, paper, scissors. Once the class was declared with public, it can be accessed. Again, if there is a non-derived class inside the same. Oh, I guess I missed that. No, I mixed that up. I mixed it up. I mixed it up. There are different assemblies. I mixed it up. I mixed it up. Let me repeat myself for the derived class, same assembly. Take it like this. Once a class has been declared, okay, say we are inside the rock, paper, scissors directory now. This is one same directory. We're inside the rock, paper, scissors directory now. And then you have your models. Then inside your models, you wrote code for, let's say you wrote code for rock. Then you created another file. You wrote another file for paper, and then you wrote another file for scissors. Now you want to communicate with scissors from paper. You're inside the paper class. You want to communicate with scissors. How do you do this? Once the paper class was declared with a public, scissors can be able to access. You can access it from scissors. They are all inside the same assembly, which is what one big rock, paper, scissors. Let me move on to the next. Don't worry, as I proceed, you will understand. Non-derived class, same assembly. A non-derived class is a class that is not inheriting from a base class. Basically, that's what a non-derived class is. I have rock, paper, scissors. Let me go back to my example. Okay, let's go back to text. Let's go back to our rock, paper, scissors example. Say there is a non-derived class, and then there is a non-derived class trying to access a certain class. If that certain class was declared with the access modifier public, that non-derived class will be able to access it. That's what it means. Then the next derived class, different assembly. Now here's how we will now be taking a look at the rock, paper, scissors and rock, paper, scissors dot test. Say for example, you are inside the rock, paper, scissors dot test directory, and you now want to access a class inside rock, paper, scissors. There are different assemblies, and it's a derived class. Yes, there are different assemblies actually. Once you have declared the one inside rock, paper, scissors as a public, you can access it right from the rock, paper, scissors dot tests. That's what that means. That one means. Then non-derived class, different assembly. If it's a non-derived class, and then they are in different assembly, one is rock, paper, scissors, and the other one is rock, paper, scissors dot test. A class from rock, paper, scissors wants to communicate with another class with a rock, paper, scissors dot test. If that class, to be communicated with is declared with public, it can be communicated with successfully. Now let's look at protected internal. That is the format. Once you get this public format, it is that public format you use to understand the rest. That's why public was the first that was listed there. The next is protected internal. Protected internal. Protected internal one, it can be accessed within the class. If it's a derived class, same assembly, you can still access it. You can still access a class or class member that was declared with the protected internal access modifier. If it's derived class, same assembly, you can still access it. If it's a derived class, different assembly, you can still access it. But once it's a non-derived class and it's in a different assembly, with protected internal, you cannot access it any longer. You have a class inside rock, paper, scissors, and then you are inside rock, paper, scissors test. You want to access the class inside rock, paper, scissors, right from rock, paper, scissors test. If that class inside rock, paper, scissors was declared with the protected internal, you won't be able to access it because one, you are not inheriting it, you are not inheriting anything from it. That means you are not inheriting from the base class. You do not take it, you did not take it as you did not take rock, paper, scissors test class as a derived class. So you're not inheriting anything from it, so it won't work. Then the next one is protected. Now, this is how protected works. If a class or class member was declared if a class or class member was given the access modifier protected, one, you can access it within that class. If it's a derived class and it's in the same assembly, you can still access it. If it's non-derived class and same assembly, you can no longer access it. If it's a derived class and different assembly, you can still access it. If it's a non-derived class, different assembly, you can still access it. The next is internal. Yes, the next is internal. And one thing to actually notice that internal is the default access level modifier. It will be declared when you do not declare any access modifier at all. So internal, within the class, you can access it. If it's a derived class and it's in the same assembly, trying to access a class that was given the internal access modifier, you can still access it. If it's a non-derived class, same assembly, that was given the internal, you can still access it. But once it's a derived class, once it's out of the assembly, one thing to actually note about this internal is very simple. Internal is public, but it's public only within a specific assembly. Yes, if you let us look at rock, paper, scissors and rock, paper, scissors test now. In rock, paper, scissors, if you have a class that was declared with internal, you can access it. Any file you create in that rock, paper, scissors, you can access it. But once you go out of that directory, which is rock, paper, scissors, then you're now going to another directory, rock, paper, scissors test, and you're not trying to access a class that was given the access modifier internal. It won't be possible. That's just internal. You can take it like this. Internal is public, but public in a same assembly. Finish. Then the next is private protected. I won't really want you to stress yourself on you understanding everything in depth. You just try to get the public, which is the simplest, then the internal, and then the private. Those are the three key access modifiers we work with in the development of C# applications. Let's briefly look at what a private protected is. A private protected, if you give a class a private protected access modifier, you can access it within the class. If it's a derived class, same assembly, you can still access it. But once it's a non-derived class and it's same assembly, you cannot access it. If it's a derived class, different assembly, you can still access it. If it's a non-derived class, different assembly, you cannot access it. So look at it, X, 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 X. Then private now, private is very, very, very easy. Private can only be accessed within the class. Finish. It does not care whether it is derived or non-derived. Private can only be accessed within a class. If once you leave that class, you can no longer access a private field, a private method, or a private class member. So let's proceed. Now let's treat these three access modifiers. I told you before, I said the basic three we treat in the program C# applications is public, private, and internal. Those are the basic three we treat. Then let's look at them one by one. The public access modifier allows us to access the class or class member from anywhere in our assembly or from another assembly. Public is like public toilet. You can access it for anybody, can access it, anywhere can access it, anybody can access it. That is it. It's as simple as that. Then private, this is the access modifier that only allows access to the class or class member from the class within itself. Once you step out of a private class, you can no longer access it. Yes, once you step out of a private class, you can no longer access it. Then the next, oh, this is a typo. The next should be internal. Yes, this is internal. This is a typo. I'm so sorry. It's not. The second was private. This should be internal. This is the default access modifier when none is specific. This is internal. This is the typo. I apologize for that. This is the default access modifier when none is specified. All class or class members declared with all class or class member. This is all class or class members declared with internal can only be accessed within an assembly. Yes, all class or class member declared with internal. That's also another type. Can only be accessed within an assembly. We mostly care about these three access modifiers in C#: public, private, internal. I really apologize for this, to be honest. It's a very, very big typo, and it took me a lot of time to make these slides. It is internal. Internal is default access modifier when none is specified. When you do not specify any access modifier for a class, by default, C# will pick it as we will give it internal. And then finally, thank you very much. And once again, I would say this: we mostly care about these three access modifiers in C#: public, private, and internal. And lastly, thank you very much for staying to the end. This is codeDynasty Studios, which is the name of the YouTube channel. My name is Dynasty personally, and I've been the one tutoring you for this video. Take care and see you in the next one.